So today we'll see why waits are required in Selenium, different kind of waits, implicit, explicit and fluent wait, practical example using waits and which ones to use. So why are waits required? Let's look at this website. It's a grocery website. I'm just going to URL one section and you can see that the elements here are taking time to load, and this is true for most of the websites. The website wouldn't load completely in a single go. There'll be some elements which might have some animation, some JavaScript, and so some elements take time to load. Now if I was to go to this URL and immediately look for an item to add, the script would fail because that element is not loaded. Hence a proper implementation of wait is required so that tests are not flaky. When you do it manually, you can see that it's taking time, and so it's important to take that into account when you are writing automation scripts. The second issue is when you write scripts, when you test them, you are testing it on your local environment, and when it actually runs in pipeline, the regression runs on a different environment. Now these environments are usually cloud environments and they might not be very stable. Sometimes the web page might load a bit slowly, and so what happens is that the regression results don't really have true failures. They are flakiness issues, and you spend a lot of time investigating and looking at failures which are not really failures. They are bad frameworks or improper implementation of waits. So it's important that we have waits implemented well so that these tests, the UI tests that are written end-to-end flows, work properly. So now we'll look at the different waiting strategies. That is the different waits that we have. The first one is the implicit wait. Selenium has a built-in wait to automatically wait for elements called an implicit wait. An implicit wait value can be set either with the timeout capability in the browser options or with the driver method that is here. This is a global setting that applies to every element location call for the entire session. The default value is 0, which means that if the element is not found, it will immediately return an error. So when I set something like this, driver manage timeouts, implicitly wait for 2 seconds, that means for all the elements that we look for in the test, in the script, it will wait for a minimum of 2 seconds before it gives up, before it gives the no such element error. Now here the problem is that since it applies to all the elements, if you're using something like this, some elements may load in 5 seconds, some may load in 2 seconds, some may load in 1 second, which means that it's difficult to come up with a single value, and you may put a bigger value which will not really be beneficial for web elements that load quickly. So this is not a good strategy if you put a high value here. Next comes explicit wait. Explicit wait is much better because you're explicitly waiting on a particular element for a particular condition. Okay, so here we define it in this manner where you have the driver and the duration for which the explicit wait is valid, and there are some expected conditions. So if you see here, there are many of them, like an alert is present, whether the element to be clickable and to be selected, to be displayed, and so these are the conditions. So you look for a specific element for 2 seconds, let's say in this case. If it is clickable in 2 seconds, then you are going to go ahead, or else you will give a timeout error. And the default pooling is 500 milliseconds, which means that every 0.5 seconds it will look for that element. So here I've given 2 seconds. If within 0.5 seconds I find it, then I will just move ahead. So I'm not waiting for an exact 2 seconds. Now one step ahead is the fluent wait. The fluent wait allows me to define the polling duration as well. So here with timeout 2 seconds, I can poll for 300 milliseconds, every 300 milliseconds. So in this case, for 2000 milliseconds, I will poll almost 6 times before I throw an error if I don't get the element. And let's say that after 300 milliseconds I get the element, then I will just move forward, go to the next step. Now this is really good when an element is loading at a different time, like sometimes in 300 milliseconds, sometimes in 900 milliseconds. So you don't spend too much time looking for that element. Okay, so it gives you more control over the time that you wait. So this is about the different waits that you have. Sometimes people have this habit of putting thread.sleep, which is a bad habit. Instead of using thread.sleep, you should use one of these waits, because thread.sleep, you don't know, today you have to sleep for 2 seconds for the script to run, tomorrow it could be more, and just changing the values to make the test run is not correct. Another thing to keep in mind is that these waits have to be used correctly, because if you put too much of time, if you wait for too much time for an element, then it causes an unnecessary increase in the regression time. And let's say that you have 10 elements, and for every element you're waiting for 0.5 seconds more, so you're waiting 5 seconds for each test, right? It takes more time. And if you have 500 tests like this, then you can calculate how much time goes. Because of these unnecessary waits, if your regression is running for 1 hour more than required, then in a week you're taking 5 hours more to run your regression, which means 5 hours of your cloud resources are being utilized without much value without much value. So you should try to use these waits well, so that you can get good results, true failures with minimum time. So let's proceed now to the code examples. So let's look at a practical example. So I am on this URL. I will click on the search, look for locator, and the first search result that I get, I click on it, and then I go to overview. So this whole process that I did, the test manually, I'm going to do it via script. So here in the script, it's a very simple script where I'm initializing a driver. Okay, let me comment out all the waits. I'm going to the URL, finding the search box, putting locator in it, okay, and then selecting the first search result, and then going to overview. Now in the middle, I've just used a start and end, so I'm basically calculating the time that it takes to find the element, and if there is an exception, I'm going to throw out the exception, and also catch the time based on the script. Okay, I don't want to quit, because I want to see how the web page looks when it fails. Okay, and then I'm putting out the wait time here. So let us run this test. Okay, so here you see that it has just put locator and it has not clicked on the first item. And if we look, we see here no search element, and it took 46 milliseconds. That means this is exactly what I was explaining in the beginning, that we come to this, we look for locator, but very fast we are looking for the first item and it is not there, because of which it fails with a no search element. And you can see it is just 46 milliseconds. It is not even waiting for a second or half a second. And now I'm going to put a implicit wait. Let's see if that makes a difference. So implicit wait means for all the elements it's going to wait for 3 seconds. 3 seconds seems to be a good enough time. So let me run this test again and see how it works and what is the time. Okay, so this time the test went ahead and it completed properly. You've gone to overview. So you see, and it waited for almost 3423 milliseconds, which is 3.5 seconds. And you see that this time the test did not fail because it gave enough time for the element to load. Okay, I am going to now, instead of implicit wait, we will go to explicit wait. In case of explicit wait, okay, I've initialized it here, duration of 3 seconds, and I'm waiting for the element to be clickable. I'm going to wait for this element, the first search option, to be clickable, and only after that I will click on it. So let's see how this goes. Okay, I'm going to trim these videos so we don't have to wait. Okay, so this one also proceeded further and it worked fine. So you see here it took 4 seconds, almost 4 seconds. So after 3 seconds, in 3 seconds it found it and then it went ahead. Okay, this is not the exact time. You see there's a wait also and plus a find element. So this time was little longer. Now let me look for, let's see how Fluent Wait works. Okay, Fluent Wait, in this case I am going to let's say poll every 300 milliseconds, and again here the condition is element to be clickable, and let's see if this helps to improve this time. This is 4 seconds, 4.5 seconds almost. Okay, so it's going ahead and it has completed, right? And now we can see the time is considerably less because every 300 milliseconds it is checking if the element is there, and that's why the moment it finds the element it goes ahead. In the case of an explicit wait, it polls for every 0.5 milliseconds. 500 milliseconds, and so you will see that it is not it takes longer time. So Fluent Wait has made it easier or faster. So if one more thing we have to keep in mind is that when we use two waits together, sometimes, I don't think it will be in this case, but at times it adds up. So if I put something like this, a web driver wait and also a timeout, then it will wait for 6 seconds or more than 3 seconds for the element. Now let's try something different. Here we have wait until, let's look for an element that is not there. So it is possible that the DOM changes and you are not able to find the XPath. How much time does it take to fail? In a positive condition, we will probably not be able to see the timeout properly. Let's see. Here what I have done is that I have changed the XPath, which means that it should fail. In case of a failure, let's see what happens. Does it wait for 3 seconds? The test is started. Okay, locator, and then here you can see no search element, so it has failed and it has taken almost 3 seconds. That means it waited for 3 seconds before it failed, before it could say I did not find the element. And let's look for web wait, the explicit wait. Even in the case of explicit wait, I have changed the XPath, so made it incorrect. So this should also fail. Okay, and so you see again here also for about more than 3 seconds it has waited and then failed. And the last one, Fluent Wait. Okay, here also it should fail. Yeah, so it waited, it failed after 3 seconds, so timeout, because we are waiting for 3 seconds before it fails, right? And let us try to combine two waits, a fluent wait and a implicit wait, and let's see if that makes a difference. Okay, so here it has not made much of a difference, it is still failing after 3 seconds. So here we've seen the three different types of waits. Just remember that when you are using waits, it kind of increases the time of your testing, of your regression cycles. So your waits should be there only when it is required. It should be there with correct conditions. You should not combine implicit and explicit waits with huge numbers. Like here, if you have 10 seconds and then you're looking for 15 seconds, it will cause a lot of delay. If a single test is having let's say 10 or 15 selectors, and for every selector or every element that you're searching, if you're increasing the time for 1 second, and each test is going to take 10 seconds more because of these ill-written or not written well waits, then if you have around 200 or 500 test cases, you will just multiply it and see how much it increases. So your test will increase by, let's say, an hour, and if that happens, if it's an hour every day, then in a week 5 hours, which means 5 hours of cloud resources you're wasting, which is not really adding any value. So your waits should be well thought of. Just don't put waits everywhere to make test run. Also keep in mind that when a test that is working fails suddenly, then it is also performance issue. That means you have to see if there are any changes that are pushed because of which the web pages are not loading, the web elements are not loading, and that should also be should be raised as a defect if there's a performance issue because of changes. So this is about waits and how you should use it. You should most probably use explicit waits correctly with the right conditions. Fluent waits should be used if it is complex and the web pages, the web elements are taking, depending on the environment, there is sometimes it loads fast, sometimes it takes a longer time. In that case you can use Fluent Wait. Otherwise Explicit Wait mostly works well and takes care of all the flakiness. Okay, so this is about weights. Do practice it on some websites that you have in your own organization or any basic websites that you're using, and play around and see how it works.